Alright class, today we're going to do Unit 12, Section 3, and we're talking about sector area and arc length. Objectives are to find the area of sectors and find arc length. Okay, the area of a sector is a fraction of the circle containing the sector. To find the area of a sector whose central angle measure is m degrees, multiply the area of the circle by m degrees divided by 360. Okay, so what we have here is we have sector of the circle right here. Okay, so you take the area of the circle and multiply it by the degree of the arc divided by 360. Remember to write the degree symbol with the M in the formula to help you remember to use degree measure, not arc length. Okay? And that's your arc degrees, or your central angle degree. Okay, so we're going to find the area of each sector, give answer in terms of pi, and round it to the nearest hundredth. Okay, sector HGJ. HGJ. Alright, so your area is the area of the circle times the central angle, or that arc measure. We've got the central angle here, divided by 360. Okay, radius is 12. So we have 52.4 pi meters squared, and we have approximately 164/6200 meters squared. And this is the area of this sector right here. Okay, find the area of each sector, give answers in pi, and round it to the nearest hundredth. We're going to do it again. So always start with your formula. Area of the circle times the area of that arc, or the central angle measurement, divided by 360. Okay, so my radius is 5. My arc is 25 degrees. And divide that by 360. So it's going to be 1 74/100 pi square feet, which is 5 45/100 square feet. All right, I'll let you read this one on your own. Radius is given, class, and the measure of that central angle is 122 degrees. Alright, segment of a circle is a region bounded by an arc and its chord. Okay? So a segment is this green area. And to find the area of that segment is you take the area of the sector and subtract out the area of that triangle. So let's apply this. Okay, so we have the sector, and we need to minus the triangle. All right, so area of a sector is pi r squared. Central angle or arc degrees divided by 360. Okay, so we have pi times 9 squared, 120 divided by 360. And then for area of a triangle, it's 1/2 of your base times your height. Okay, so what we have here here is 120 degrees, same as the arc. This is 9 and this is 9 because, excuse me, those are radiuses. Okay, so what I need to do is I need to find out my base and my height here. All right, so I'm going to redraw this. This is 9. Okay, if this is 120, this right here is 60 degrees, and if these are, this is an isosceles triangle, if this is 120, 180 minus 120 equals 60, therefore these here are both 30 degrees, so this is 30 degrees. So I can use my 30, 60, 90. Okay, some of y'all are getting confused on the 30, 60, 90. Okay, so here's your 30, 60, 90 rule. Across from 30 is your side. Across from 60 degrees is your side square root of 3. Across from your right angle or your hypotenuse is the side 2 times side. Okay? All right, so I can find the side because I'm given the hypotenuse right here. So let me erase this. So if the hypotenuse is 2 side and it equals 9, my side is 4.5. Therefore, across from the 30 is 4.5, and across from the 60 is the 4.5 times the square root of 3. Because across from your 30 is your side, and across from your 60 is your side times square root of 3. So now I have everything I need. I take 1/2. Well, my base is the 4.5 times the square root of 3 doubled, because this segment is just half of that, okay? So I'm going to take 2 times 4.5 square root of 3, and then my height is the 4.5. So if we key all this in our calculator at one time to be as precise as possible to the nearest hundredth, you're going to get 49 75 hundredths. And we are talking about centimeters, so it's square centimeters. Okay? All right. We check time here. And we are good. So I'm going to be quiet. Y'all are going to do the same thing on this one. See if you can figure this one out on your own. Okay, what I have here is, here's my right angle, S. This is 4, this is 4, this is R, and this is T. So my base is 4, and my height is 4. Key all this in your calculator. And you're going to get approximately 4 57 hundredths square meters. Okay, in the same way that the area of a sector is a fraction of the area of the circle, the length of an arc is a fraction of the circumference of the circle. Okay? So arc length is like if we were to take a piece of string and put it right here and measure it, and then make it a straight edge and measure it with the ruler, okay? So it's length, it's not degrees. Okay, so to find the arc length, what you do is you take the circumference and times it by the central angle measurement and divide by 360. Or that arc measurement and divide by 360. So let's apply this. Okay, so we're finding length, which is your circumference, times the central angle or the arc measurement. Okay. So 2 pi radius is given. And let's see, we're trying to find this right here. Actually, no, back up. We're trying to find this right here. Okay? So that arc degree is 134 divided by 360. So when you key this in your calculator, you're going to get approximately 1. Now, students, because we are talking about length of a side of that circle, it's like circumference. It's not squared, it's just centimeters. Okay, last one. I'm going to be quiet and let y'all try this one on your own. Yep, well, that's it. Y'all have a good evening.